is the paper called Brief Recap 64 to 66, and we are ready to start with number 7, which says write as a polar equation. Honey,
I wasn't there when you gave it up.
well, I don't know. I don't have any. I don't know. Take a picture of somebody's. I'm sure it's stapled to something, Francis. If you look, I'm sure you've got something.
Well, today you handed it out. I was like that.
Okay, but I always keep them for you and hand them out the next day. So I'm sure you've got something in there. And if not, just take a picture of somebody else's. Okay, now we're going to rewrite this as a polar equation. Now, what does that mean? That means no x's and y's, only r's and thetas. So here we go. What's x equal? R cosine theta. What's y equal? R sine theta. Take a look at that equation. What are the variables in that equation? R's and thetas. Is that a polar equation? We're done. That is so easy. Okay, and then number 8. You've got a couple of numbers in polar form or trigonometric form. These are polar form, trigonometric form numbers. And we're going to do some stuff to them. All right, how do you multiply them? How do we multiply those two numbers together? What do we do? Millie?
Multiply the coefficients and then add the degrees.
Exactly. So we're going to multiply the r's, like she said, and we're going to add the angles, like she said. So there would be the answer. That's all there is to it. When we multiply numbers in polar form, we multiply the r's and add the angles. Okay, what about division? All right, what is going to be the division of those two numbers? Z sub 1 over Z sub 2. What's that going to be? 3/5 CIS negative 20. But we talked about that the other day. We have these really strict rules about polar form, and we don't like to see negative 20. So we need that same angle, but we need it named differently. So what would it be? 340. This is not what Caitlin was talking about on her quiz. Caitlin was talking about we had a negative R value, right? That's a different problem. Here, we have an angle. We want to keep that angle, but we got to name it differently. So we add 360 to it. Good. All right, what does this mean? No, that doesn't mean magnitude. No. That means the conjugate. That means the conjugate. The bar over the top means the conjugate. So in polar form, what about the conjugate? R stays the same.
And the other one is negative.
The angle goes the other direction. So the magnitude stays the same, so R stays the same, and the angle goes the other direction. So instead of going, remember conjugates, 3 plus 4i, 3 minus 4i. 3 plus 4i would look like that, right? Over 3 up 4, 3 minus 4i would look like this. So if the original is going up, the conjugate is going down the same amount. But here we are, same place we were a minute ago. You're not allowed to have a negative angle. Every time you find the conjugate, you're going to have a negative angle, but then you're always going to have to fix it. So rename that angle so it's acceptable. 310. And there is your conjugate. Now what does that mean? That means the magnitude, the length of the number if you were to draw it, and that's the same as R. The length of the number is R. This is the length of the number right here. That's R. So that's just it. All right, good deal. That is done. Now, we got several other things like that, but let's skip ahead and do a pre-test. So let's just do the first one, the first pretest you come to in your packet. It's not number 2, so it's just the one called pretest. And let's see if we can get this cranked out. So we are on pretest 6466, not the number 2 one, just the regular one. You might want to fold your paper. The answers are at the bottom. So I think I'll fold my paper so I'm not tempted to look down there. There's only 14 questions. And I'm going to try to do some of these without a calculator. And then I'll use a calculator as necessary, but I want you to practice without a calculator. All right, so here we go. Convert to rectangular coordinates. All right, so what does that mean I am looking for? X and Y. So I need to find X and Y. Here's my R, here's my theta. Now kids, what does X equal? This should be like your mantra. X equals R cosine theta. So I need X. X is -2 cosine 30. Y is -2 sine 30. Now, if you wanna, if you don't like this negative R, and you want to change that, like Caitlin did on her quiz earlier, that is fine, but totally unnecessary. Because your job is to figure out X and Y, and X always equals R cosine theta. So I'm just going to go ahead and leave it just as it is, but I'm going to find the sine and cosine of 30, which I don't need a calculator for, right? Patty, what are we doing, sweet pea? Okay, let's put that away and let's take some good notes here on this pretest. Okay, so what's the cosine of 30? Guys, cosine of 30. Root 3 over 2. So negative root 3 for X. What's the sine? 1/2. So -1. So my answer is negative root 3 comma -1. Remember, if the original is an ordered pair, then your answer is going to be an ordered pair. Okay, that was easy. Anybody have a question about that? Seems easy enough. All right. Convert to polar coordinates. Now, this is number 2. What am I looking for then? I'm converting to polar coordinates. So what am I looking for? R and theta. All right. So how do I go about finding R and theta? I draw a little picture of it. Over 1, down 1. So here's R. R is root 2. Now, I'm not going to use a calculator. I shouldn't need one. I should be able to tell from this picture that this angle right here is 45. Be careful. Don't put 45 here. What goes there? 315. This point is in the 4th quadrant, right? Make sure that the angle you write is in the 4th quadrant, all the way around. Now, the next one is exactly the same. So let's do it exactly the same way. That point is down here. Okay, so let's find R and theta. So what would R be? eyeball it, or you can do the Pythagorean theorem, either way. What do we get? Wyatt, as my mother would say, wake up and smell the coffee. It's 4. And it's 4 because, what do I get when I square 2?
4.
What do I get when I square 2?
4.
Times root 3 squared?
12.
That's 12. 4 plus 12 is 16, and the square root of 16 is 4. How big is this angle then right here? Take a look at that triangle. Again, if I'm not allowing you a calculator, there has to be something special going on.
60 degrees.
That's a 60. Be careful. I've got 4, comma, not 60. It would be 240. So there are the polar coordinates of this number. Now, the issue is, did you notice the direction said R has to be negative for this problem? Now, R will never come out negative. This is step 1. This is always going to be step 1. Now you're going to make R negative simply because the direction said. And when I do that, when I just make R negative, then what's going to happen to my angle? It's going to change by 180, so it's going to go to 60. These 2 points are exactly the same point. This problem wanted this version of it, R less than 0. Standard form, rectangular form, complex form, Cartesian form. What is the standard form of this number? All right, what form is that? That right there is what form? That's polar form or trigonometric form. Now we want the standard form, complex form, Cartesian form, rectangular form, which means what? What form am I looking for? X plus yi. How come I don't want an ordered pair like I wanted over here? These other problems I got ordered pairs. Why am I not getting an ordered pair over here? Because I'm not starting with an ordered pair, right? This is not an ordered pair. That's a number. And so I got to end up with a number. Okay, but I need x and y. How do I find x and y? X equals r cosine theta, y equals r sine theta. Now again, we should be able to do this without a calculator. What's the reference angle for 150? 30. And you know your sides. Miss Ford, how can you expect us to remember that? I do. You must. You must remember the sides of your 30, 60, 90s. Okay, so what's the cosine of that angle? Negative root 3 over 2 cosine of Jason over hypotenuse. Come on, guys. So that is negative 3 root 3 over 2. Sine.
1 over 2.
Positive 1/2. So that's going to be 3/2. So then I got my x and my y, so I'll write my answer. Negative 3 root 3 over 2 plus 3/2 I. X plus yi. X plus yi. Now, of course, if you're doing this on a calculator, you would just type this in on your calculator and then you'd have some kind of decimals instead of the radicals and fractions. Okay, number 5. 2x minus y equals 7. We've already done one like this today. Your job is to write it as a polar equation. That's the first thing we did, the first problem we did today. Do you remember how we did that? Just take out the x and plug in r cosine theta. Take out the y, plug in r sine theta. And it's that simple. Remember, if you want polar, that means you've got to have r's and thetas. I have them. I'm ready to go. Now, 6 is a little bit more complicated. We're going the other direction. Now we're going to change this to a rectangular equation. Okay, who remembers my hint? Change. I mean, I could do that. I could change secant into 1 over cosine. I probably wouldn't. I want to just figure out what is secant. I want to substitute in the definition. So what's secant? R over x. How do we know that? Because it's reciprocal of cosine, and cosine is x over r. So we have r equal to 3 r over x. Now, that, no matter what the function is, that's going to be a fraction. Every function is a fraction. So let's clear the fraction. And what? X equals 3. So that equation right there is the same as x equals 3. Number 7 is exactly the same. We're doing the same thing with number 7. Okay, changing this into a rectangular equation. So what's the first thing you're going to want to do? Probably change sign into y over r. Now clear the fraction. So it's a little bit different this time. But what? R squared. What's r squared? X squared plus y squared. Good. So now you have an equation. Now you have an equation whose only variables are x's and y's. X squared plus y squared is r squared. Every time. Every time. All right. Number 8, negative 3 plus I, negative root 3 plus I, change into trigonometric form. Now, trigonometric form is the same as polar form. So that means what? I'm looking for r's and thetas. And my answer is going to be this. This is trigonometric form. That's polar form. So what do? How do I find an r and a theta? I'll draw a picture of it. So negative root 3, positive 1. What's my radius? 2. Now watch it. This is theta. This is theta. But I gotta find this angle first. That's a 30. So this would be 150. And there you go. There's your answer. There's the polar form, or the trigonometric form of that number. Got it? All right, number 9. We've already done some of this today. Z sub 1 is 3CIS 10. I'm using the shorthand. I've got the longhand on the paper. I'm using the shorthand when I write it up here on the board. You can use either one, whichever is less confusing for you. Now I want to multiply them. I want to divide them. Okay, so here we go. What is their product going to be? Multiply these two numbers. The product will be 12 CIS 82. Perfect. When you multiply numbers in polar form, you multiply the R's and add the angles, right?
Yep.
Now the division, watch this now. The division,
Four-thirds CIS, 62.
Patty, what are you doing, sweetie? Getting ready to have a Hulk moment, don't want one. Alright, this is Z sub 2 over Z sub 1, so what am I going to have? 4/3 CIS 62, right. You just got to watch the order of the division. Make sure you're dividing in the right order. Alright, what does this mean? Magnitude of the first number, so the magnitude of the first number is 3. The magnitude of the number is just R. And then, what does this mean? The conjugate. And when I do the conjugate, I leave the radius the same, but the angle becomes negative. And then I fix it. So that would be 4 CIS 288, if my arithmetic's right? No. Yeah. Is that right?
Yeah.
Okay. Number 10. Find the cube roots. Okay, here we go. Find the cube roots of this number. Now, cube roots mean 1/3 power. So I am raising this guy to the 1/3 power. And I will use DeMoss, because that's how I raise numbers to powers. So let's see. In order to do that, I'm going to have to change my number, right?
Yeah.
So I'm going to change my number into polar form. So I'll draw a little picture of it. Over 4√2, up 4√2. You ought to be able to tell me right now what this angle is. Yeah, that's got to be 45. I have a 45, 45, 90 triangle. Now you're either going to do the Pythagorean theorem or use what you know about 45, 45, 90 triangles to find the hypotenuse, the radius. What's the radius? It's 8. 4. It's 8. Now how can the hypotenuse be 4? Whoever said that needs to be embarrassed. The hypotenuse cannot be 4 if the sides are 4√2, right? Now, if I square this, I get 16 times 2, so I get 32 if I square that. I get 32 if I square that. 32 and 32 is 64, and the square root of 64 is 8. So my number is 8 CIS 45. And I am raising that to the 1/3 power. Alright, now what does DeMoss tell me to do? How do I raise this guy to the 1/3 power? I take 8 to the 1/3. Alright, what's 8 to the 1/3 mean? The cube root of 8, which is 2. 8 to the 1/3 is 2. And then what do I do? 45 times a third, which is 15. DeMoss says no matter what the exponent is, you take the radius to the power, multiply the angle times the power. Now, am I done? No, because this problem has 3 answers. Remember, root problems have multiple answers. Root problems. If you are rooting, you're going to get more than one answer. So, there are 3 answers to a cube root problem. They all have the same R. They will be how many degrees apart if there are 3 of them? They're not 180 apart. They're 120 apart. 360 is a revolution. If you divide that up into 3 equal pieces, they're 120. So since they're 120 apart, the next answer is going to be at 135, and the next one at 255. And if you add another 120, you get 375, which is the same as 15. Here are the answers to the question. Right? Now, number 11 is almost exactly the same situation. We are going to do exactly the same thing. What is the only difference with number 11?
It's not a fraction.
It's not a fractional exponent, therefore it's not a root, and therefore there will be just one answer. But we're going to do everything exactly the same. So what are we going to do first? Draw it. We've got to change it to polar form. Alright, so here we go. We now need to figure out R. So, figure it out. This sport's not going to be sitting on your shoulder when you take the test. You're going to have to figure this out. It's 4. If you square this, you get 12. If you square that, you get 4. 12 and 4 is 16. Square the 16 is 4. How big is this angle? 60. Be careful. The angle you want is 120. So 4 CIS 120 is your number. And that is what you are going to raise to the 4th power. So here we go. How does that work again? How do we raise this to the 4th power? 4 to the 4th, which would be 256. And then 120 times 4, 480, which is too big. So we'll shrink that down to 120. So here is my answer in polar form. There's my answer in polar form. There are no directions here, but I bet on the test it's going to say answer in rectangular form, complex form, Cartesian form, standard form. Okay, so let's change this back to rectangular form. Okay, what does rectangular form mean again? What am I doing here? What am I finding? I need X and Y. So this is what I'm shooting for. How do I find X and Y? If this does not roll off your tongue, I don't know what's wrong with you. X equals R cosine theta. Y equals R sine theta. So if you're using a calculator, if you're allowed to use a calculator, you're just going to type it in, boom, 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 get these weird decimals. We're going to answer exactly. That means no calculator since we can. I know this is written right over here, but I'm going to pretend it's not. Start from scratch. What's the cosine?
-1/2.
-1/2. So I have 256 times negative 1/2, which is negative, what's half of that? 128? What's the sine of 120? Root 3 over 2. So that'll be 128 root 3. So my answer, remember we're shooting for this, my answer is negative 128 plus 128 root 3i. X plus yi is my rectangular form. Number 12, name the classical curves. What are the classical curves? 4 of them. What are they? Rose, limaçon, the rose, the limaçon, the spiral, just spirals in general, and the lemniscate. That's right. So the rose, limaçon, spiral, and lemniscate, those are your classical curves. Okay. Plot the following points and label them. Alright, so you've got some graph paper. So you're going to plot these points and label them. Alright, so here we go. Alright, so 3 comma 120. 3 comma 120's on the 120 circle out, 1, 2, 3. Everybody got it? So there's point A, 3 comma 120. Uh-oh, what about B? B's in radians. So I probably need to change that into degrees. So I have 5 pi over 4. Okay, pi is 180. A fourth of that is 45. Times 5 is 225. So I am coming around here to 225, and the radius is 4. So there's point B. Alright, 2, negative 15. So that's on a circle with a radius of 2 and an angle of negative 15. Would you say there's point C right there? Negative 15 degrees. Negative just means go down. Now, D I have an issue with. I can't plot a negative R. You can't plot a negative R. You gotta make it positive. So when I make that R positive, what's gonna happen to that angle? It's gonna change by 180 degrees and become 150. So that point is getting plotted on the 150 line, 2 circles out. So here is point D on the 150 line, 2nd circle out. Okay? Now, 14, you're going to graph these on your calculator. Okay? You're going to do it on your own. I'm not going to help you. But I want you then, once you get them graphed on your calculator, you need to transfer them over to one of your little grids. Because that's what you'll have to do on the test. So you're going to get the picture on your calculator, and then you're going to transfer it to your grid. Now, before we start, what shapes do we have here? You should know before you begin what you're going to be graphing. What shape is this? That's a rose. Now what do you know about this rose? It's going to have 3 leaves and they're going to be 4 long. So when you set up your window on your calculator, how far over and up do you need X and Y to go to accommodate this rose? They gotta go over at least 4, probably 5 just to be safe, right? But at least 4. Now, what's this? That is a lima sign. Remember, the only classical curve with an addition or a subtraction in it is a lima sign. Right? Now, the biggest value that cosine can be is 1. So the biggest this guy can be is 5. So set your window like maybe at -6 and 6, and you're going to be able to see that lima beam. Now, when you transfer it over, obviously your picture's not going to be perfect. But if it's a 3-leaf rose and their length is 4, then you better have them coming out to the 4 circle. And you better have it reasonably symmetric. In other words, don't be drawing some picture that looks like this. That's not right. Make them 4 units long and have them reasonably symmetric when you put them on your graph paper. All right, so do that right now. Yes?
I have a question. How do you make the
No, you ask a neighbor. We have gone through this and gone through this. You ask a neighbor. I'm going to set my grids up, and then I want you, as you get them, to come up and put them up here so we can see what they look like.
I know, I don't understand it.
Don't forget, if your picture looks a little bit funky, zoom square. We'll straighten it up for you. Zoom square will give you a very accurate graph. Okay, I need volunteers to put your picture on the board. You only need to do one.
Sam volunteer.
You don't need to put them, come up and put them both up.
I should have said that loud. Just so she could.
She made you go up there.
Yeah, I know. That's why I was scared to do it. Right. Yeah, that's why.
Okay, Zach, do you have them done? Okay, go put this one up here. Katie, do you have them done? Put that one up there. Let's look at them and see what they look like.
Remember it's like we were talking about like schizophrenia and how some people like turn into a vegetable? That's what happens to me in this class. I think I have schizophrenia. I just turn into a vegetable. I don't remember anything.
Close enough. Is it going out 5? Yeah. All right, now, he's got them 4 units long, perfect. My grid is off because I didn't graph it very well. They're all the same length. They're all exactly the same size. So you should have something that looks like that. These are actually up here, but I'm not gonna, that's fine. This is fine. That's the 3 lead rows. And then over here, she's got, it's a little bit funky here, but she's got her nice little Lima sign, and it's got an interior loop, right? Comes out to 5 over here on this side. So both these graphs would get full credit because they have the right shape, sized right, reasonably symmetric. There you go. Okay? So on your test, you need to be able to, whatever I give you, you need to be able to graph it and then on the calculator, and then reproduce that on the paper like they did up here. Got it? Okay, here's the good news. Our homework is due tomorrow, right? And we have a test on Friday. That's our good news.
So then what's the bad news?
So tomorrow we have the long period and we will do another review. And and then Friday we're ready for a test. Okay? All right. Good job.